Welcome guys, we're going to push on now with part 2 of the PS4 Syscon stroke UART stroke the NOR flash. What we're going to be doing on this episode is having a look at how to read the NOR. I've picked the FAT for the simple reason it's probably one of the easiest of all to read and to read on the board so you don't take it off. So what we'll do, we're going to have a peek at the chip, and I will show you how I go about reading it. So let me just get focused up, and we'll pop over to the microscope. As you can see, it's a 16-pin package, which is the only one of all the PS4s that is a 16-pin. And it does create its own issues because although it's very similar in connections to the 8-pin, this does have an extra pin to contend with. And that is a reset pin. When it's off the board, it's not an issue because you can put it into a 16-pin adapter to 8-pin and it reads it. And the reason why it's no problem is because the pin 3, the reset pin, is left floating. When it's actually on the board, it's connected to a pull-down resistor, which keeps it low, which means that under normal circumstances, reading it with a reader externally, the reset pin is low and you can't read it, so you have to force that pin high. It's something we can easily do. And the idea of this is to show you how to do this as easy and cheaply as possible. Now, the only downside of this is the length of time it will take for it to be read. We're going to use the CH341 reader, which is the I'm sure you've all seen it, this little baby. Let me just grab it for us. Okay, now what I'll do, I'm just going to take the leads out of it and we'll focus in a bit closer. There we go. Alright, you've all seen this particular reader, I'm sure. It's available from Amazon. It's anywhere between £7 and £12. The only thing is you're going to need to modify these because they come as a standard 5 volt output to the not only to the supply, but to all the pins, the I/O ports, which will damage the chip. So we need to modify it, and that's to convert it to 3.3 volt. And it's a simple case of lifting one pin off the board, which is this pin here, which is the last pin in the chip, and connecting it to a wire and connect it to the 3.3 volt supply, which is the center pin of this regulator. And at the same time, connect it to pin 9 of the chip, which in this case is the end of that capacitor there, C4. If you Google this, you'll find these mods all over the place. They're very easy. So I won't go too deeply into that. So we've got our programmer. Now we need to be able to connect to the chip. You can solder to it if you feel competent to do so, but there's absolutely no need. What we can do is we can use clips. Now Ali have just started doing these clips. They're not the best there is, but at the price they're pretty good. They're about £7 to £8 I think for 10 clips. They work pretty well. I'll show you under the microscope so you can see a little bit more. Right, let's get under the microscope and we'll find the NOR. Okay, let's just straighten the old microscope up a bit. Okay. Oh, okay, sorry about that. That'll make you feel a bit seasick moving around. My microscope is actually, the bracket's gone a bit wonky. Right, there we go. These clips, right, they're on AliExpress. And what I'll do, I'll try and focus in on the end. What you've got is a nice little forked tongue that pops out, and you can just clip them on the pin as like so. The only problem with these, they got a tendency to pop off, so you do have to play around a bit to get them to stay put. But at the price, they're great. They really are, for £7 for 10. Now, I will show you alternatives. They also do one which is a little bit smaller and quite a good idea. And it's just a post, like so, you put your plug on the end, and you can push that pin in and try to, like so. And when you do, what happens at the other end is, I'm sure you're going to be pretty well ahead of me if I can get my hand out the way of everything, because it's damn awkward to grab hold of these things. They really are. As you push it forward, the little V-clip comes out the end. The problem is with these, I've got a nasty habit, I just keep popping off all the time. Forgive me putting my hand in front of the microscope, because the biggest problem with them is actually getting hold of them. Right, I've just knocked one on the floor. Right, now that one you can see is on, and it's off. That is the problem with them. Great idea, but they are pretty poor, which, if Ali's watching, I hope you are, you'll perhaps look into it, because they can be made better. They're a great idea. They need something on this part here, even if it's just roughing it up or making it so you got perforations or some kind of herringbone on there so you can actually grip the thing. So I'm not going to bother with them. Now, if you're feeling really crazy, you can go out and buy a set of Easy Hook original clips. Now, these are absolutely phenomenal. Now, they're quite basic design. They got a little trigger on the top, but they got a tiny end. If I can hold it still enough, you see. Now, let me just squeeze the trigger. Clip it on, and there you go. Now, the nice thing about these are they actually will sit flat on the board, because the end is so thin that the angle of the pin doesn't reflect and try lifting the thing up off the board like so. And of course, then with the weight of the cables on it, they just pop off. These are the best option, but you're sitting down for this bit because you're going to need to. $20 each, not for a set of 10 each, 15 UK pounds each. Absolutely ridiculous price, but they're made of top quality material. They don't tarnish. The spring inside is top quality. But for this, you're only going to do it probably once or twice, so I wouldn't worry about it. Go to the Ali ones, and you're just going to have to persist with it. Right, now I want a quick explanation of the issue of the reset pin. On this chip, out of the 16 pins, we only use 9. 4 of the chips this side aren't used, 3 this side. What we do, because we do, that was good English, isn't it? What we're going to do is to supply the chip from an external source. That's what this lead here is. In my other videos, you'll notice that was fitted when we started doing work with the Syscom, which is just back there. So on part 2, we're going to be looking at getting the data out of this little beast here. So you haven't got to worry about the supply pin, which is pin 2. And you haven't got to worry about the ground pin, which you can see there is pin 9. You can see it's connected to the ground plane there. Now, what we're going to do is that 3.3 volt post here is we're going to supply the power to this chip externally and what we're going to do is supply it at about 2.7 volts. The reason being is if we try and feed it at 3.3, all these other chips are going to try and wake up and work, and it will stop this from reading. So that's the idea. Unfortunately, these will read down to quite a low voltage, so we can get away with that little trick. So as the two pins are already connected, the ground and supply, that's two less to worry about. Well, however, we do need to make sure the ground from this board is connected to the programmer, because if it isn't, it's not going to work. The other thing we've got to do, as the reset pin here is tied to ground, pin 3, via a resistor, you can do several ways. You can either very carefully lift this pin off the board, you can follow that via, find the resistor and take the resistor off, or just do what we're going to do, and that's put a clip on it. Now, what we're going to do, as we're not using the supply, because we're going to feed the board directly, on the programmer, I'm going to go back to an overhead. Let's see if we can do it this way. I need to get a bit closer. Let's get the thing to focus. There we go. The camera's being a little bit temperamental at the moment. Right, so that's the board. Now we want to use the SPI, which is, if you turn it over and look, it tells you that the SPI part is the first eight pins of the board, or the socket there. And pin 1, if you look here, there's a little legend here, is the pin 1 is towards the knobbly bit. So here's our board we've made up, which is just some pins on a PCB with plugs on. That's all that is. Now, what we're going to do is we got, actually on that, the 8 pins, we've got 7 wires. Okay, so the 8th pin here is left with nothing on it for a good reason. So I'll pop that in the reader, like so. Okay, and then what we're going to do is wire this up. Now, if it was an 8-pin chip, we'd be wiring it up pin to pin, as in like pin 1 on here is the brown one to pin 1, but it's not, because this is a slightly different pin out. So what we're going to do is wire it to the corresponding pins. So I'll bring that up for us to have a look at. Just bear with me a second. Right, okay. So that's our schematic, or that's our layout of the chip. They're both the same chip, but what we've got to do is we've got to connect the connections that we've got from the programmer, which are configured as an 8-pin, to the 16 pin. So if you look at the layout, pin 1 to pin 1 wouldn't work, because they're two different things. One's chip select and the other one's an in-out port. So what you need to do is to look for the same. So if you say, right, your reader is connections as the 8-pin, so we need to take pin 1 from the reader to pin 7 of the actual SOIC. So what we'll do, we'll go over to the board and then we'll just get this laid out roughly right, because what you don't want to do is be moving these about once you've got them hooked up, because they will come off, I can promise you. Well, the first thing we got is the ground lead, which, as you can see, is on pin 4. That can actually connect directly to the board. Now, if we go, let me just let me get a slightly wider angle. There we go. That's where I've got these little earth tags here, so that can sit on there. Now we'll need to set that off the board for obvious reasons. We don't want any shorts. And what we're going to do now is, so pin 1, which is on mine, I use the colour of the wire to match the number of the pins. So pin 1 would be brown, as brown on resistor color coding is 1. So pin 1, which if you look on the chip on the drawing we had up, was, if I remember right, we said was chip select. So pin 1 from the programmer here, this pin, needs to go to pin 7 on the actual chip on the motherboard. So what I'm going to do, I'm going to pop the scope across so that I can bring it up and show you. So pin 1 goes to pin 7, chip select to chip select. So what we're going to do now is take pin 8 on the 16 pin, and as you can see, that's in out 1, so that's pin 2. So from the programmer pin 2 we go to pin 8 on the actual chip. So there we go. There we go, that's on. This is where you end up knocking pins off. Now the reset, this is the one that's the problem. What you need for that one is a clip with just a piece of wire on and a 1K resistor. Now I'll show you that before we go too far. If I can just show you under here, there's the clip, there's a wire, and there's a 1K resistor. That's the old type, which I'll come back under the scope. It's what you call a wire through type. So it's like that, and that's the colours you need: brown, black, red. Okay, so that's 1000 ohms, and that's just basically terminated just as a bit of wire, that's all. And you'll see it'll become obvious in a minute. Now this has got to go on to number 3, or pin 3. As you can see already, pin 7 has already come off. Actually flat, it's at an angle. Okay, that'll be on there. Just got to watch they don't touch. It won't damage anything. It just doesn't, you'll just get corrupt readings, which you don't really want. So let's see if we can get the reset on pin 3. Okay, that's just about there. The other end of the reset, we're just going to leave for the moment. I'll come back to that in a minute. So then we're down to first pin, which is S103, and if you look on the 8-pin device, it's reset on 103. So that, as far as we're concerned, is S103, and that will go to pin 1 on the 16. So pin 7 from the programmer goes to pin 1 on the actual NOR. And pop that on pin 1. We're halfway there already. Okay, so we're going to make our way down the other side of the chip. If you got the board on the bench, if you put it so you've got your Ethernet port towards you, so pin 1 of the NOR is towards you. Now we're going to go from the top left, as you look at the chip, top left down. So the top left is write protect and serial in, or IO2. So IO2 on the 8-pin is pin 3. So from the programmer pin 3, we need to go from there to pin 9. Right, so now that possibly is going to keep pinging off. That is an awkward one because of that. There we go, that's not too bad. So pin 9, now pin 10, we needn't worry, that's connected to ground. And if you remember, pin 4 from the programmer goes to the ground, and we've connected that to the actual ground on the ground plane on the board, that pin that we soldered onto the board. If you haven't got a pin, you just need a piece of wire, solder it onto an earth point on the board. Then from there we don't use the next 4 pins, so we're down then to the last 2 pins, 15 and 16. Well, 15 is IO0, and that is pin 5 on the programmer. So 5 on the programmer goes to 15 on the NOR, on this particular NOR. So I think we're on there. And then, believe it or not, pin 6, which is the clock, goes to pin 16. And that's virtually all the pins. So if we can get that on without yanking that one off. You see what I mean about them coming off. Okay, right. Well, they're all connected so far, so good. Okay. Now we get round to this pin 3. Now, what I'm going to do is go back to the overhead. So there's the header, and as you can see, it's connected to the NOR. The pin connections that I showed you, that's how it's wired. Okay. The only pin we haven't got connected on the program is pin 8. There's nothing on it. It's just a blank pin. Now, the voltage, the VCC, which is pin 2 of the NOR, is actually connected to the 3.3 volt rail on the board. That's what this red lead is, and that's what that soldered point there is. That's how we're going to supply it. So we don't worry about that. But there will be on this pin from the programmer, when we start the software, there'll be 3.3 volt. And that's what we're going to use to pull the reset high. So we're going to use it. It's quite simple. All we've got to do is pop up, if you can find yourself a lead, we're going to pop onto pin 8. Okay, and then that resistor, we're going to just push it up inside the connector. What we've got from pin 3 on the NOR, which was the reset if you remember, is actually now connected to what was the VCC pin on the programmer. So we're coming off of pin 3 here, round here, through that 1k resistor there, 1000 ohm, and then onto pin 8. So there we go, that is now all connected. What we've got to do now is sort out an external supply to power the NOR. What I'm using is an external power supply, and if I can just get to it so I can set it up, there we go. I'll show you that in a moment. I'll just try to find the leads. Where are we? There's the ground lead. So the ground lead, I'm going to just clip on ground. There's the other ground I was telling you about to the programmer. So that goes to pin 4. All it is some of these edge connectors, these things, just snapped a few off and I just soldered them onto the board. If you're doing this as a project, what I would suggest you do is get an old board that's probably scrapped. This has got no HDMI port or chip on it. It'll never work, but the chances of finding a dead NOR and a dead Syscon is pretty remote. The idea of part 1 was to get you into the Syscon. Part 2 is to get you into the NOR, or to get the data out anyway. So we're connected up, have a visual check, make sure nothing's shorting. You got your 1k resistor in. We've got our little CH341 programmer modified, and now we've got to set up an external supply. So what I've done, I've got an external supply, and we've got the ground on the board, and on that 3.3 volt point here, which I covered, I believe, on the Syscon, we're going to send 2.7 volts down it. It has to be around 2.7, okay? And you can set your current for probably 50 milliamps, something like that. So we'll connect that on there, like so, and that's insulated, so it should be good. And then what we're going to do is I'm just going to put the supply on. I'm just going to move the microscope out of the way for a second. And we're going to see what sort of current we're using. There shouldn't be much more. Oops, hit the right button, boy. Got a choice, here we go. We can see we've got 2.7 volt and we're drawing 17 milliamps. That's good. That's where you want to aim for. If the voltage is too high, then it will draw a lot more current, and the other items like the Syscon, the Southbridge, anything that's on the 3.3 volt rail can actually wake up and cause the problems, and you won't get a proper reading. So make sure you're about 2.7 volt and it's drawn about 17 to 20 milliamps. That is normally pretty good to go. So I'm going to go over it now with the microscope so you can have a look. Now, just going to have to, don't want to move the board, so bear with me because it's going to jump about a bit while I get it set up. Right, there's our, let me just hit the focus button, one push, here we go. There's our NOR, so pin 1's bottom right as you see it, and as you look at the circuit, pin 1 of the NOR there, pin 1 is S103 and that goes to pin 7 on the programmer, and then pin 2 is already connected to the board. So that picks up on the 3.3 volt. Pin 3 reset, that goes to a 1K resistor and goes to pin 8 on the programmer. Then 4, 5 and 6 aren't used. Pin 7 is chip select. So pin 7 from the NOR goes to, I'm going to find it, pin 1 on the programmer, which is chip select. And then where are we? Chip select. Pin 8 is IO1. That then goes to pin 2 on the programmer. Pin 9 is IO2. That will then go to pin 3 on the programmer. Ground, you don't worry about. That's already connected. What we do is connect a ground point from the board to the programmer. You can put it, say, on the copper, I'll show you in a moment. I don't want to move the microscope at the minute. I'll just go around the rest of these. So we go across from pin 9, 10, and you've got 3 no connections, or was it 4? 4 no connections on that side, yeah, 4. And we're down to pin 15, which is IO0. That goes to pin 5 on the programmer on the CH341, standard SPI connections, and then pin 16 goes to pin 6. So that's what we got. If you were looking to pick up a ground point, I mean, like them copper bits here, you can see by the socket. Let's go down here. There you go. All this is ground, so you can solder it on there, the ground pin, and then I'll go over to the programmer above it. I'm just going to have to refocus because we're going to go up a bit. Let me hit the focus button. Okay, so now we're above the programmer, so you can see now the connections are pretty much, it's the bottom row of 8, so you can see the actual programmer. There's the, you can't quite see the actual post that you use for clamping, but it's there underneath the brown wire up here. I'm then going from pin 1, which is the 4th pin up on the left side, downwards. So on the programmer, that's pin 1, 2, 3, black is 4, across the green is 5, blue 6, mauve 7, white is 8. Now white is normally the VCC, but in this case we're using it to connect to the 1K resistor to the reset pin, which is pin 3 on the NOR. Sort of a little bit of a bit to take in, but I hope that is pretty much explanatory. Just get it the focus, hang on. There we go. Okay, so That's back in, just to make a final check they're all connected, but so they are, so all good. Right, now let's move out of the way. We've got power supply, we've got the board wired. So we've got our supply on here, 2.7 volt, the ground is here. The ground for the programmer is plugged there, and this is all connected up as per the diagram that I showed you. All we need now is a USB. So we're going to pop along with our USB and be very careful not to shake any leads off if you can help it. Right guys, so we'll go over to the computer, and we've got the software open, Neo, which I'll make sure is in the one of the zip files that will be with this part 2. So open it up, and down the bottom here on the right, you want to just see that it can see your actual programmer. It says if it can't find it, I'll tell you what. So can I actually, I don't want to pull the cable out in case I pull a wire off, but it will tell you down here, it'll be a red mark saying it can't find the programmer. So it can see the programmer, it hit detect, and it's read the ID of the chip, C22019, and it's listed 3 chips that it thinks are what we've got on the board. But the chip on the board's got an F, not an E, but it is a 25635. The E is fine, okay? So hit that, hit select, and then go up here to the top and hit the read IC, which is a little green arrow, and it will start reading. Now, as I say, the downside of this is it does take time, unfortunately. The 341 is only a single channel reader, and the NOR is quad, so it's reading a quarter of the speed it could be read at. But hey ho, the programmer is cheap and cheerful, and it works, and that's all we need to worry about. So we're reading the NOR. Once that finishes, we'll save it, and then we'll go from there. Okay, so what we've dumped the file and we've saved it on 3. What you need to do is to dump at least 2 files. Basically, compare the 2 files and make sure that they are the same. Because if they're not, then you've got an issue. That means something's gone wrong in the reading, and you need to do it again, unfortunately. So what we're going to do is go to the editor, which is the HXD, which I'll put a link, or at least somewhere to get the file to download. You need to open the file, the 2 files you downloaded. If you open one, so it shows up in the editor here, the second one you can just drag and drop it onto the screen and it'll appear here. Then you need to go to Analyze, Data Compare, and basically it's come up and it says they're fine, they're okay. So we've managed to dump 2 files and they've turned out the same. If they don't, you're going to have to look at make sure that the connections are right and the connections are good both ends. Make sure that if you have to modify your reader, then make sure you've done that right. Make sure that it shows up in your your USB and your device manager. But the thing is, when you open the software up, it will tell you if it can't see the programmer. And then secondly or thirdly and finally, make sure that you've got your external supply. It's about 2.7 volts. It should be somewhere around, I don't know, at the moment it's now shown about 16 milliamps. Doesn't need to be a lot. And it's still actually on at the moment. So right, now what we've got is the files we've read here, and what we're going to do now is have a little look at one and see how good the files are. Now there is free software which I'm going to use, as you can get access to it. It's PS4 Wii Tools. Now that'll do. Okay, so we're going to go and open the file, so I need to go to the folder. Where is it? Junk, there we are, 20. And there's the files in there. So we'll open up numbers, we'll take the first one, number 1. And there's your file. Now this is telling you your current firmware. Look, if this had been a good board, look, firmware was on it was 6.5, so that would have been a nice one to wind back. But as this is a dead board, and it's never going to work, I don't think. But never mind. It tells you the board, a bit about it, and everything else. It tells you the UART patch is not on. You can see there. Now you can patch the UART just by selecting flags, which is pin 1 there, and there's one there. You select one and you can turn the UART on. So if you hit 1 and enter, UART was set to on. So I had to do it twice because I missed the key there. But so that's now telling us the UART is on. That was the first file, wasn't it? Yeah, that was the first file. So what we're going to do is we'll pop out of that and we'll go back, and we'll go back to select another file, and we'll select number 1 again. And if you look now, it says that the UART here is now on. That's something we're going to need for the next part 3. What I'm going to do with this is basically not go much further. Probably do the UART, might be part 3 or 4 actually, because we need to go and look closely at how, on what is rolling back and how it's done. Although you will see that probably on one of my other videos, but I'll quickly go through it as best I can, because it's not a quick thing you can teach. But the as you can see on here, this is basically a new bit of free software, and it's getting better with every update. It really is. When you check the UART, check the NOR, it tells you what firmware you can go back to, what is active, although I'm a little bit puzzled why 1.6 is active. I think 8.3 is active and it can go back to 6, but as I say, this board, I don't know even how old it is. It's donkey's years old. Yeah, it's not much else there to worry about for the moment. Down here you can select your flags. You can do various things with these. You can put a memory test on, so you can turn that on, then boot the machine. You see, every time you change anything, you have to then load it back into the NOR. So we're going to keep this simple for the first go, and we're just going to turn the UART on. But as I say, there's a lot more this will do. So we're going to come out of that now, and what we're going to do is go and actually send that file that we've now modified. We're going to send it back to the actual NOR. So there's our board, there's our file that's modified. It's now, we've renamed it to UART, so we know it's modified. We need to go back to the Neo programmer, and as I say, it's come up already. And if you look at it, down the bottom here is where it's telling you that the program is connected. Programmer frames you. If it wasn't, it'd tell you it's not there. Okay, so if it detects, there's the chip on the top, we'll select that, and if you look down the bottom here now, it's telling us the chip, the voltage, it's telling us what the voltage the chip should be on. We're not running on 3.3 volt, don't forget, we're running on 2.7 from an external supply. Now what we've got to do is load the file into the chip that we've actually modified. So we need to load that file in there, open, and then we can send the file to the actual chip. That's here, Program IC. Now this takes a long time. It takes about 20 minutes. So what you're going to have to do is basically wait till it's finished, and once it's done, that's it. That's as far as we're going to go for this particular part. Now if you get any problems where it comes up and it shows in red down the bottom here, you should see a green line going across here. Should it come up in red, then you've got a problem. You're going to have to go back and restart the read. Should that happen, hit the stop button, close the program, open the program, detect it again, make sure it's all good, go and reload the file that you want to program. So go back to open, reload that file, and then go back to the right and try again. If you can't and you keep getting errors, you have a look closely at your wiring and everything else. It's a difficult one. Sometimes things can go wrong. You can get corruption where suddenly you hit read and there's nothing in the chip. If that should happen, fortunately you've already made 2 dumps, if you remember. These two, your first 2 dumps, what you need to do is put them safe and don't touch them. Make a clone, just do a copy and paste and do 2 new ones, and then any mods do to them. So if you get in trouble, you can go back. If you get to the point where the chip seems to have got mucked up and you can't do anything with it, then you'll have to redetect the chip, and you probably have to go for an erase, that one there, which is the one with the red cross on. Totally erase the chip and then basically just rewrite and try again. And you should be okay. I don't think you'll get any problems. As I say, it can happen though, just be warned. That's why I say this is all best done with a spare board, just to learn how to do this. And hopefully you'll get something from it. So what we're going to do, we're going to leave it there for now, and I'm then going to start on part 3. What I'm going to do on part 3 is show you how the UART part works. Now I'm going to have to use a working board for that, because this board I've got doesn't work. What I suggest you do, if you're doing this on a working board and you're quite happy to do that, then fine, you can follow along. You just need to get a UART, which is something like the FTDI. I'll put links in. Well, I'll put the link in with this one because I'm not going to do the UART on this one. We've already established the connection for the UART on this board, but if you are using a board that doesn't work, you won't be able to run the UART, but you've gone through reading the NOR and the syscon and writing to them both. So when we get to the part where we do wind something back or downgrade something, you'll be fine. You'll be able to follow that. Now I've done lots of downgrades and they're up there, but they were aimed at sort of more the novice end. I'm not being rude to anyone, but I've had so many emails asking, you know, how do we do this? How do we do this? You've all got to start somewhere. So the reason I've done this particular little run of videos is for the guys that have never ever done it and have no idea about doing it. Now, as I say, I'm not being condescending or anything. I'm just trying to make sure that you learn something without losing something. So, okay, what we'll do next time, we'll go through what the UART does. We've enabled it, I showed you that, and then once we've got the UART working and you can see the UART, Then we can start looking at the process of downgrading and also looking into the feasibility. Not all Syscons can be downgraded. Some Syscons, later chips, can't even be read. They're a different chip altogether. So, as I say, it is a bit of it's not 100% guarantee that when you do this, you're going to get the right board and get everything in the right place first time. Christ knows it took me half a dozen goes to get the grip, to get my head around it. And I've been doing it all my life. So, Anyways, I'm waffling on a bit. I do apologise. I'll see you on part 3. Take care.